What's going on, everybody? Zane here, back with another video. For this one, we have the rotate image problem. Given an array of integers or array of vectors, we're going to take this entire vector of vectors, which is also called a matrix, and we're going to rotate it 90 degrees, and so that it looks like things being shifted, which in this case is this. So I'm gonna actually pull up something I drew here. So we have this as our initial matrix. And what we want is for it to look like this, which is essentially just taking the entire matrix and shifting it 90 degrees, which is why it's called rotate image. We're rotating it 90 degrees. Taking a look at our actual answer here, we see that the first row is 741. 741 seems to be obtained by first taking this column here and transposing it onto this row, and then reversing those numbers. So when I say transpose, I'm referring to something like this. So if we take a look at just, we'll use the example as the previous one. So let's say we have a column of 1, 4, 7. When you transpose it, it becomes a row of 1, 4, 7. And then what we could also do is, once we have transposed it, we can reverse it so that it's 7, 4, 1. So that's how we obtained the first row. We took that column, transposed it, then reversed it. And that is the essence of this entire problem. I'm going to just bring this back. That is how we got to 7, 4, 1, and that's how we can iterate through each of these elements and within each of these vectors and properly transpose and reverse. So let's go back to the code here. I'm going to remove this out. So we have a return type of vector of type int, and we're also passing in the same, and we're going to call this matrix. Let's bring this colon down, or this bracket down. All right, so like we discussed in the example, what we're going to do first is we're going to transpose the matrix, then we're going to reverse the matrix, and then we'll just return the matrix after it's been transposed and reversed. So this function here is going to be our driver function, meaning it's going to do stuff after we've defined these two functions. So let's just minimize this, go up here, and let's create our two functions. So we're going to create a transpose function. Let's first establish what this is going to return. Since we're just doing or manipulating a particular matrix or vector, we're not actually returning any values. So we're going to create a void function. So we'll do void transpose, transpose, and it's going to pass in the same thing as the standard vector of type int. So we'll do vector of type int, and it's going to be a reference to the matrix. Now here is where we'll start doing some of our code. What we first want to establish is the size of the rows and the size of the columns, and those are both going to be integers. Let's go back to our example here. Let's just pretend we're going to loop through and establish what our rows and our columns are. So since we know that this is a vector of vectors, so like this. So within this blue vector bracket, there are 3 additional vectors. And if we were to loop through, this vector is one item, this vector is another item, then this vector is another item. Inside of each of these vectors are 3 additional items. So the vectors themselves are items, and the items inside of the vectors, or the numbers inside of the vectors, are also items. So when we do our first iteration, our first for loop, that will be these 3 vectors. Our second for loop will be the elements inside of these vectors. So that's very important, because when we go back to our code here, we're going to be doing a double for loop to get inside of the row and then get inside of the column. So let's first establish the size of the row, which will just be the size of the matrix. And then the column is going to be the matrix at the 0th index, and that's size. So again, if we were to be inside of our vector, it would be at this element, but at the 0th position. So we would want the actual numbers. So now that we have our sizes established, let's loop through our rows. So it'll be int I equals 0, I is less than row. This is the same as typing in matrix.size, but since we already have a variable for that, we can just type is less than row. And then we'll do I++, open up the brackets. Now we need to go for the columns, so we'll do columns. So we'll do int j equals I plus 1. J is less than column, j++. Now the reason we're doing I plus 1 is because we are accounting for the first element after the 0th. So we want to make sure that we're starting off on the I plus 1 element of this first row here. We don't want to start off at 0 because we're not going to be swapping anything at 0 here. So once we're at this point where we're in our columns, what we'll do is we'll use the swap method to swap specific values. And let me just draw this out here. So we're trying to transpose. We want it to go from 147 here to 147, like this. So we would want to take the element here and swap those. Then we want to take the element here and swap those. One of the main characteristics of these elements can be shown if we take a look at the specific indexes of, let's pick this number. If we're using our double for loop, which we are right here, what is going to be the index of this? It would be 0, 1, because we're at the 0th vector and then the first index of that vector. So 0, 1. Then the opposite of that would be 1, 0. 1 would be this vector here, and 0 would be this number here. So this right here is matrix at 0 at 1, and this is matrix at 1 at 0. And if we swap these two, then we have the proper placement. So here, all we need to do is do the matrix at I at j, so the element that we're at, and we want to swap it with the inverse of that, j at I, instead of I at j. I believe that should work now, so let's actually test it out. I'm going to comment out the reverse because we haven't done that yet. Run the tests, and this is our input, 1, 2, 3, 4, 5, 6, 7, 8, 9, and it looks like 147, 258, 369. So this seems to have worked because this column of 147 is now a row. We've transposed it. Same with 258, transposed, 369, transposed. Cool. So now all we need to do to actually solve this problem is to reverse these numbers so that it's 741, then 852, then 963. So let's code that. Let's go up here again, and we'll create a new function, and we'll call this reverse. Okay, so reverse might not be the best name, so we'll just say reverse stuff. And in here, we'll also pass in the same thing, which is a vector of type int, and it'll be a reference to the matrix. And we'll do the exact same thing again for the sizes of the rows and the size of the column. And now here, we'll loop through just like we did regularly, just like we did before. And now we want to loop through our columns. Now the columns, we do want to start at 0 because we're only going to go through half of our column. The reason we're only going through half of our column is if we take a look again over here, after we've transposed our values, so we have 147, 258, 369. Once we've transposed it, we'll look over here, right here. So this is our transposed information. Take a look at the middle column. The middle column is the same as our expected. So we don't necessarily need to work with all of the matrix again. We just need to work with half of it. So again, after we transposed it, it looks like 4, 5, 6 right down the middle. The expected output is also 4, 5, 6 because we only need to go through half of our entire matrix. We don't need to go through all of it. And again, this will only work if this is like a perfect square type of matrix. But I believe in this situation or all these cases we do. So we're good to go. So again, we start at 0. We'll do half of the columns, and then we'll do J++. Open this up. Now we need to do one more swap. And what are we going to swap? Well, we're going to swap the element that we're at, but what are we swapping it with? So over here, we swap the element that we're at, which is I at j, with the inverse of that. And that allowed us to swap this with this. So that's cool. That makes sense. But if we take a look at now reversing, how can we actually deal with that? So what would we need to do? We need to, I'm going to erase this a bit. Wow, let's not erase. Okay, let's just, oh, you know what? I think I can select this and move this aside. Yeah, cool. Okay, so let's draw this out. So right now, after we've transposed our data, we have 147. Let me draw this out here. We have, whoa. We have 1, 4, 7, 2, 5, 8, 3, 6, 9. Come on. 3, 6, 9. Sorry about that. 3, 6, 9. Okay, so in order to get this here, this is our answer. In order to get it in this format, we need to take the half here and swap it with the half here. So again, let me change the color. So we want to take the half here and we're going to swap it with the half here. So how can we do that? Well, what we know right now is that matrix at I at j would be, let's just say, this element here. We want to swap this with this. This value here appears to be the value at the end of our matrix, or at the end of our row. So we can do matrix at I, so our still at our first row, but we want it at the end of the column. So we'll do column minus 1 because column is the matrix's size, or the column size, at 0, of course, and then subtract 1 so that make sure that it's within range. Now, there's one more piece that we need to deal with here, but let me actually run this and show you what this here alone does. And let's do reverse. This is reverse stuff. Let's run this. Okay, so it looks like the first one actually passed. And that's great, but then we go into things that are a bit larger, and we notice that the output here is 610, 786. Here it's supposed to be 687, 610. So what seems to be happening is we have 687, 687, but then 6 and 10 are still in the same order. So it appears like there's an issue with our indexes. So in order to make sure, this kind of was by fluke, but if we were to subtract j from our second piece of the index, from our column, that will actually solve our problem. You'll see here now the test cases have passed. So I think the key takeaway when dealing with something like matrices is swapping and kind of eliminating other options that do not work or are close to what you're trying to get, and also just trial and error and seeing if subtracting 1 would work with your ranges, or subtracting maybe I or then j, and just working around with what you know. This might be a little bit easier, the column minus 1, because typically we do, let's say, matrix.size minus 1 to make sure that we're within index, because we were trying to get to the end of the index and account for that 0th index. But I think trial and error is definitely a big portion of this as well. That's how I was able to get this. So I think that's it for this one. Again, all we did was transpose the information, reverse the information, and then we just returned our matrix. The two functions are up here, and we then just returned our matrix at the end after the functions were called. So if you guys have any questions, comments, feedback, please let me know in the comments below. Otherwise, hit that like and subscribe button, show me some love, and I'll see you in the next one. Peace.